Greetings, my little triglets. Welcome to section 3.2. We're going to talk about polynomial functions and their graphs. And don't forget the ever-present fun in polynomial functions. And graphs. Polynomial means many numbers, so polynomial. Now, one thing about polynomial functions is that graphs have to be smooth and continuous. Otherwise, they are some other kind of function. They can't be sharp turns or have breaks in them. They have to be smooth and continuous. When we go to graph polynomials, we like to look at the end behaviors. Now, end means front and the back, so not just the last part, but the beginning and the end of the graph. So the basic formula is ax to the n, so y equals ax to the n. So we have a number a, we have the variable x, and then another number n, an exponent. So let's talk about when a is positive. When a is positive, the main thing is that it's going to rise to the right. The graph will rise to the right. Now there are two possibilities for n. So if n is even, we have the graph doing the same thing at the front as it does at the end. So if we're rising to the right at the end, then it's going to do the same thing here. So if I'm rising to the right, I'm also going to rise at the beginning. If n is odd, then we're going to do the opposite. So if we're rising to the right, we're going to fall to the left, or at the beginning. So that's if a is positive. Now, if a is negative, first of all, it doesn't rise to the right anymore. It falls to the right. Okay, so then we also have n. If n is even, it's going to do the same thing. So if I fall to the right, I'm also going to fall to the left. If n is odd, then it does the opposite. You can remember that because the O's go together. Odd means opposite. In fact, the P's could be upside down D's, and we could get really close. It almost looks like a reflection here. If you're looking into a beautiful pond and you write the word odd on a piece of paper and then you hold it up to the pond, it's going to say up. So just remember that. So if it falls to the right, that must mean it rises to the left if n is odd. All right, so let's look at a couple examples here. So if I have y equals x to the fourth minus 4x squared, we really just want to look at this part of it. That's our y equals a to the, or sorry, ax, let me back up. Back it up. Okay, so we're just looking at this. We have a 1 in front, so this is our y equals ax to the n. So a is positive. That means we're going to rise to the right. So I know I'm going to be that. Now we look at the n. N is even, so that means we're going to do the same thing at the beginning. So it's going to look like that. So we might list it as up, then up. So up is at the left side, and then up is at the right side. So they both do that. Now, what if I have it in this form? Pay close attention here. Negative 4x to the third times x minus 1 squared times x plus 5. This is different. This has parentheses. So what we have to do is think ahead and think about distributing out the parentheses to see what ax to the n would be at the beginning. So if I FOIL all this out, and remember I have a 2 here, so if I FOIL this, this is going to be x squared. This is just x to the 1, and here I have x to the third. If I multiply all of those together, I'm going to get x to the 6th. Okay, so that's going to be our highest power. This gets multiplied also, but there aren't any other numbers that are going to go with it, so the negative 4 becomes the a. So a is negative. That means it's going to fall to the right. 6 is even. that means it's going to do the same thing at the front. So this one, whoops, goes down and down. Okay, so if it has parentheses, you have to distribute out those parentheses to see what ax to the n is. Now, a good way to just look at it is just to look at the exponents of all the pieces and add them together. That's what it's going to end up being. All right, let's talk about the zeros of the polynomial. When it's in this parentheses form, we're going to get zeros. Let's go to the next page here. Zeros, in other words, are the x-intercepts. We also call them the roots, or we call them the solutions to the polynomial. So let's check out this polynomial. Y equals x to the third plus 3x squared minus x minus 3. And we want to find the roots. Now, if it were a quadratic has x squared in it, we have two methods to do that. We can factor, or we can use the quadratic formula. Now this one has an x cubed, so that changes things. And there's no greatest common factor to take out front, so we have to come up with some other methods. In class, we're actually going to use the graphing calculator. Okay, so we can call this a cubic function. So we're going to either use the graphing calculator, which I will show you in class, or we're going to factor by grouping. Grouping is a lot like the four-spot method you used back in Algebra 2, but it's already kind of broken up for you. So I'm going to take those two and factor out what they have in common. Looks like x squared, which would leave me an x plus 3, and think of distributing that back in, so I undistributed the x squared. These two looks like they have a -1 in common, which would leave me with x plus 3. So factor by grouping is only doable if these match. Now those two I'm going to bring out front because they are what's in common. And then what's left over, the x squared minus 1, goes in the second parentheses. Now at this point, we're supposed to set equal to 0. So this one, x plus 3 equals 0, I'm going to get x equals -3. This one, there's two ways to do it. The first way, we're going to just set equal to 0, and I get x squared equals 1. When I square root both sides, I get x equals plus or minus 1. So there are my three answers. There's 2 here and 1 there. I need 3 total. And I said there's two ways to do this one. The other way to do x squared minus 1 is to realize that that's a difference of 2 squares, and you get x plus 1, x minus 1 if you do it in the parentheses. And then this is your -1, that's your plus 1. So you still get your plus or minus 1, it's just with the difference of 2 squares instead. So those would be the roots, or the solutions, or the x-intercepts, or the zeros. They all mean the same thing. All right, so if I were to graph this, let's go back and let's say our zeros. Our zeros came out to be, let me rewrite those parentheses. I have x plus 3, x plus 1, and x minus 1. So our x's are really -3, -1, and 1. So you go in those parentheses. Let's look at the graph. So I'm going to plot -3, -1, and 1. Okay, from here, they're all powers of 1, so that means I go through the x-axis. Okay, what if it was a power of 2? Power of 2 means I'm going to bounce off the x-axis. Power of 3 means we flatten out and then go through the x-axis. Well, we don't have anything but powers of 1, so we're doing good here. Now, it was x to the third. X to the third, this is positive, and this is odd. So positive means I'm going to rise at the end. Odd means I'm going to do the opposite. So I'm going to fall. So all you have to do next is go through each of the points. I'm going to go through this one, through that one, and through that one. Okay, if I had something like, let me go to the next page actually. If I had something like x squared, and then x plus 1, and x minus 3 squared, well, this would bounce, this would go through, and this would bounce. Okay, and the highest power, if I put a 1 in there, if I add these three, would be x to the 5th. And there's no number in front here, so it's just a 1. So this would be positive and odd. So let's see how that graph would look. So first of all, I got to get my zeros. This part here, you set it equal to 0, then x is just going to be 0. So 0 is one of them. Set this part equal to 0, I'll get negative 1. This part equal to 0, I get 3, but because of that 2, I have to say multiplicity of 2. Sorry, I have to do that here also. Let's put that in. All right, so let's put in 0, negative 1, and 3 here. Okay, so now I know I have odd and positive. Positive means I'm going to rise to the right. So I know I'm going to end up like that. Odd means I'm going to do the opposite. So I know this one is going to start low. So now I have to do what these tell me to do. So at negative 1, I'm just going to go through because it's a power of 1. At 0, I'm going to bounce. So I need to bounce. And at 3, I'm also going to bounce. So I'm going to go up, come down, and bounce off of there. So there's your general picture of a graph with multiplicities. All right, so that's it for now. When we come to class, we'll get the graphing calculators out if you have one. TI-86, TI-84s are good, 84 plus, 89s are okay. I know the 86 the best. I can fake my way through the 84s, but I have enough that we can share in the classroom. So, all right, Trig love is all around you. Feel the love and life is good. Ta-ta for now.